Can everyone hear me?
Yeah.
Yeah. Okay. Oh, there's one here. Is this on?
Yes.
Yes.
Okay.
Not the other one.
Is this one on? Okay. Assuming you're in the right room, this is L2, I think. I hope. I'm going to be talking about mocking and when to mock, when not to mock, and also a thing I developed called MethodFixtures. It's not a great name, so any improvements or suggestions are welcome. Okay, so as I was saying, look at a few problems with mocking and then MethodFixtures. Okay, making a few assumptions. It's only a 20-minute talk, so we're going to have to race through a lot of things. I'm assuming everyone here knows Perl and can write tests using testmall or similar, and understand the reasons for writing tests, because I haven't really got time to go into that in 20 minutes. And also, we're mostly looking at testing code directly. There's obviously other types of tests, sort of user acceptance tests and things. So we start by looking at a unit test. And we've got an example here. Can everyone read that? It's not hugely important if you can't, but it's just a very basic class with a few attributes and builder methods on the attributes. And then we have a corresponding sort of unit test for it. Again, this is a trivial example. The issue comes when we're testing code which is using our unit. When we're testing a unit in isolation, it's very easy to just test the inputs and outputs. But as soon as you start having dependencies, and here we've got another trivial example. We've got a dog class, and the spots on the dog. I haven't used. In fact, it doesn't need a circle at all. Are going to be defined as circles. So if we look at our corresponding unit test, we're using our unit that we've tested. Anyway, it's all fairly straightforward. What's the problem? Well, it starts to put coupling into your test suite. When you're architecting a system and so on, you spend a lot of time trying to remove coupling from your software, and now you're putting it back in your test suite. If you change anything, you've got to update more tests. Example, if the value of pi changed for some reason, not only would you need to update the circle tests which are actually using pi, you've also got to update the values in your tests in the dog test, which is using circle tests. Again, it's not a problem in this trivial example, but once it's over a huge code base, these things start to add up. It makes it harder to refactor or reshape a system. You're also loading unrelated dependencies, which is making your tests more fragile. If the sort of upstream dependency is broken, then you can't run your tests even if it's completely unrelated to what you're trying to test. They're testing code more than once. Again, in this example, it's trivial, but suppose it took a minute to calculate the area of a circle. You'd only really want to be testing that in your test for the circle class, not in anything that's used it. This slide's a bit vague, but we're not really testing it under different environments. We're just basically running the code, and that's that. You need to start thinking about what you do if the package isn't available, or have a different behavior on a different system. You're not testing optional dependencies. I'm not testing edge cases. Here's a random diagram made of sort of complexity in the system. So you're trying to test a unit in it, but there's a lot of dependencies sort of either way. So mocking. helps us to isolate the code that we're interested in testing. We have increased control over the inputs and outputs. We can fake behavior on other environments. We can fake error behavior. And here's another rubbish diagram. So I'm trying to, you're interested in testing the units, you need to be able to control the inputs and outputs, then you've got an isolated unit test, which is maybe desirable depending on your system. There's lots of things on CPAN to mock objects. There's just two examples. I'm sure everyone here is pretty familiar with mocking. The basic idea is you create a fake object with the same interface as the one you're pretending it is. You only actually need to replicate the interface that's used during the test. And then pass the object into the code that we're testing. It can get a bit awkward if you can't pass it straight in. If you're not, it depends what you're testing. And in the simple example earlier, the unit test, you can pass the fake object straight in. If the object is part way through the code, it can generate it itself, or it can get it from another dependency. It can get a bit more awkward. Again, it depends on the size of the unit. It may not be practical just to consider writing a unit test for a single class or a single method. In the real world sort of code base, you may end up with the units being some error functionality of the system, and maybe that's as small as you can get easily. Not always ideal. There's an alternative. You could make a mock object which is actually wrapping the original, and then manipulates that as appropriate. There's an example which we're using at work where there's a database object. It's sort of wrap of a DBI handle and so on. And this can appear anywhere in the code. It just calls, give me a database connection. And so they're very hard to actually mock. But by overwriting, sort of monkey patching the method which generates it, you can get a database handle which has a real one, but you can alter it or either pass through methods you want or catch them yourself and give different behaviors. And so that's quite a nice way to actually access a test database in a system that hadn't been designed with a test database in mind. I guess you might want to have mocking methods. There's probably even more to do this on CPAN. Basically, you're changing the behavior of a method in place. And so principles of that. In our test suite, we want to identify the places that we can sever the connection between dependencies. It could be a dependency on a database or a disk, a remote API, a web server. They might be called directly by the code in the test suite, or they could be called by a dependency. And an example of Perl, the good thing about Perl, you can manipulate anything anywhere. So as long as you can identify where you want, you can then just make a nice cut and replace that. One thing a lot of people don't do when mocking is to actually validate that what they're putting into the mock method is correct. And this goes to objects too as well. When you see people using a mock method or object and it's just returning back something, but they're not actually checking that they've called it with the right arguments or the right information, and also called the correct number of times. That's what you want to do. Okay, so the quick run through mocking there. Now, problems with mocking. You're writing extra code. I mean, you want to be testing the code you've already written. You don't want to be writing more code in order to do it. You're potentially re-implementing logic. You've got logic in your system, and you're duplicating that to try and get mock objects to work, and there's the possibility of introducing new bugs. Are you writing test suites for the mocked methods and mocked objects you're introducing? And this one can be quite important. There's no real link between the real code and the mocked code. So you make a mocked method and a mock object, the test pass, and then a year later someone's changed behavior. You'll never know from your test. Obviously, in an ideal world, you'd have 100% test coverage, you'd have full integration tests, end-to-end testing, and so on. But if you're applying tests onto a legacy system, you're probably just writing tests for the bits you're working on, bits you're changing, if there's no test suite to begin with. So once you start mocking, you need to think what you're actually testing. You can write fancy tests, but are they giving you any confidence in the code you're testing? And that gets back to the principles of, you've got to think, why am I writing this a test? Wait. Okay, so I thought of this thing. I called it MethodFixtures after database fixtures, and it's not necessarily the best name, but I thought of a better one. And I was sort of surprised that this didn't seem to exist anywhere really. And the basic idea is you run the code and record the inputs and outputs to a chosen method. And then on subsequent test runs, you just read the saved data. And then you can throw an error if you don't have anything to match those inputs. It was inspired by this package, which I now seem to be the maintainer of. That's no longer does power. But this is basically drop-in replacement. If you're using any code that uses LWP user agent, you just use this in your test suite, and it's record and playback mode. It records all the network traffic and then plays it back. And it's quite handy. Sorry, but my code is matching the inputs. This just replays them in order, and it's not actually saving what's being the request being sent. It's only saving the HTTP responses. The advantage of matching inputs is we can add or remove or reorder the tests without re-recording them all. So it uses hook Lex wrap, although it may not for much longer after I found the undocumented behavior. And the basic idea is we're installing a wrapper around the mocked method. Before the method runs, we look to see if we've got any saved data that matches those inputs. And then afterwards, if we've run the method, we then save the return data. So there's some sort of pseudocode. Let's sort of say what we're doing. The wrap method is from Hook's Lex wrap. So basically, if we're recording, we just drop straight through to here, otherwise we retrieve it. And what we store and retrieve is based on the @ for the size. So what we need to do to get this to work, we make a storage key from the input arguments, and the idea is that's a replicatable key. So our coder has to customize it, because you might want to strip out something like timestamps or string-fi objects, things that won't be the same next time you run the code. And we also need to think about recording the context, because obviously methods in Perl might behave differently depending on if we're in a void, scalar, or list context. It allows you to choose a storage mechanism, so it comes with a pretty crude one, which just saves it on disk.
Okay.
Sorry?
Everything okay?
Oh, yes, thanks, yeah. Here's an example of using it. We just load the package, make an object, and we choose the method that we want to mock. And then we run it in record mode, and then you probably want to add the fixtures into your code repo, and then on subsequent tests it will use the saved data in here. Here's an example of what the file storage saves. So there's 3 files there, the bottom one's been truncated, and they're basically data dump outputs, in the theory that that's rereadable in. And as you can see, we're passing in an object. That's probably the call to, that's the sub $self, because these are object methods. And the output, we're also recording the version numbers of the files, and you can optionally get your storage cluster warn if there's, or die even if there's a mismatch, and that will hopefully allow, if the format ever changes, you can know about it and break the code. Oh yeah, that's saying optional storage version numbers. I ought to be looking at this, not that. A few things about feature development. I had the idea that you could record the inputs and outputs of a method and use that to generate unit tests for that method. Might be interesting, I haven't looked at that yet. So to sum up, because this has been a bit of a rush in the 20 minutes. Yeah, consider mocking or recording methods early on in the development. You want to identify any code that's expensive to run. That could be financially expensive. You may have to pay for API access or various Amazon cloud charges and things. It could be computationally expensive. Might be storage guide, might be using up IDs. If you're generating user IDs from a system, maybe you don't want to waste them running a unit test every time that someone commits to build. Tests that are non-repeatable. Sometimes code isn't repeatable, and that may be the desired behavior of the system. Example, if you're making a post request, you're changing something on the server, you've got to then reset things, maybe in a test database or whatever, in order to rerun it. It's quite easy just to record that, and then you don't need to bother about that until you need to re-record the data. Things that call it external systems. Has your build server running Jenkins or whatever, has that got access to things, remote APIs, web servers and stuff? If you've ever written CPAN things, you often get failures from systems that don't have network connections, and you put something in a code to call Google or something, and of course no good machine can. Also, if you're calling external systems, it's making your test more fragile. What happens if the server's down, unresponsive? It could be an abuse of a remote system. You may have permission to access someone's API, but they don't want you using it hundreds of times a day for testing. You need to find some balance between testing the units in isolation and together. You might also want to think about adding mocked code into a library for reuse across the test suite, because it starts getting a pain to repeat things across test files. Don't want your test code too fragile or awkward to use. Okay. Mocked objects used as necessary. Watch out for implementing logic. Mock methods that try and slice off externalities. They're quite handy for changing config and data. Again, think about reuse across your test suite. On the other hand, sometimes just having a database fixture, just spending time to build a test database or having test data you can reuse might be more appropriate. And as always, danger in introducing bugs. Method fixtures, it's similar to mocking methods, but using real code, hopefully introduce fewer bugs and possibly simple to use. And that's it, and that's 20 minutes.